This is another U-substitution example, and we have x to the fourth. It's going to be the indefinite integral of x to the fourth times x to the fifth plus 7 all to the fifth power. Okay, dx. And again, we're going to try to get this into this u to the n du form because we have the chain rule involved, so it makes everything a little more complicated. So first of all, I'll rewrite this so it's a little bit more convenient. So I'll put the x to the fourth over on the right side here, because that's going to probably be part of my du. So I'll write x to the fifth plus 7 to the fifth times x to the fourth dx. And you can combine some of these steps. I just like to show every step to make sure we're all on the same page. And then we see that we've got something to a power. It's a function. So we have a composite function. We have two functions, something to the fifth and then something to the fifth plus 7. So they're similar, but we do have a binomial in this function. So we're going to let our u be what's raised to the power. So we'll let u equal, and that's going to be x to the fifth plus 7. So I'll rewrite this now, and instead of writing x to the fifth plus 7, I'll just put u. Don't really need the parentheses. U to the fifth. So there's my u to the n. And I've got x to the fourth dx. So again, now we've got our u to the n, but we need a du here. Again, our differential doesn't match with our variable here, so we need to match that up. So how do we find what du is to get du in here? Well, we just take the derivative over here. So the derivative of du, and that's du dx, and we're going to have dx dx, so we just write the numerators there. And the derivative of x to the fifth would be what? 5x to the fourth. The derivative of 7 is 0, and it's going to be dx dx. And the denominators are both dx, so we can just ignore those for right now because we're just dealing with differentials. And this almost looks the same. The only difference is I've got a 5 here, so I need to remove that, or move this so I can have a perfect match here of x to the fourth dx, x to the fourth dx. So I'll just divide both sides by 5. And that makes us 1/5 du equals x to the fourth dx. And now you can see we have a perfect match here. X to the fourth dx, x to the fourth dx, these are the same. Exactly the same. So instead of writing x to the fourth dx, I write 1/5 du. So now I'll rewrite this as the integral of u to the fifth times 1/5 du. And I'm almost ready to go. This almost looks like u to the n du. I just happen to have a 1/5 here, so I'll just move this out in front using the constant multiplier rule. And I've got the integral of u to the fifth du, and I'm ready to go. This is just exactly like what I have here. U to the n du, u to the fifth du, where n is 5. Now we have to carry the 1/5, so that's going to equal 1/5. And then the added derivative of this will be u to the n plus 1, so u to the, and what's 5 plus 1? 6 divided by 6, plus c. And 1/5 and times 6 in the denominator is just 1/30. Or I could put 30 in the denominator. That might save a little bit of space here. And I've got u to the sixth plus c. But what's my u? Well, I go back up here and look at my U-substitution. I know it's x to the fifth plus 7. And that's all there is to it. If you follow all these steps, write everything down, Very easy.